Hey everyone, my name is Robin Godwill, and this is an introduction video to a video series in which I'll be showing you how to program industrial robots with Grasshopper and Rhino 7. In this case, we will be using the Robots plugin. It's simply called Robots. This is the plugin I'm talking about. There are other plugins that can program industrial robots. However, this is the one that we will be using in this video series. And I will be specifically looking at universal robots. In this case, this is a UR10, should be the same for a UR5. But the Robots plugin can also program other kinds of robots, for example, ABB robots, KUKA robots, and Staubi robots. And you should be able to follow along. So if you have any of these kinds of robots, you can still follow this video series. However, there are certain sections and certain parts that are specific to universal robots, so you might need to skip them or figure out how to do the same thing in your specific with your specific robot brand. You should have basic understanding of Grasshopper, of the user interface of Grasshopper, how to use Grasshopper, how to connect components, how to create groups. If you've never used Grasshopper, you should probably go back, do a few tutorials, basic tutorials on Grasshopper before coming back and attempting to program robots with it. If you're using universal robots, either at your university, your job, and you want to use Grasshopper, I also encourage you to install the UR-Sim offline simulator. And you might be asking, why do I need this simulator if I can also simulate this in Grasshopper, as you see here? But this is basically simulating the software that runs directly on the robot. So before we send something to a real robot with a real tool attached, moving in the real world, we might want to send it to this simulator to check for any errors that might not come up in Grasshopper but will come up in the robot simulation, and of course also on the real robot. I will link a video in the description where I show you how to install the UR-Sim offline simulator, whether it is for the CB series of universal robots that you can see here, or the E series universal robots that looks a bit different, but installing and running it is pretty much the same. All right, in the video series itself, we will go over installing the plugin. We will look at how to get robot libraries and to actually get specific robots. We will look at creating robot targets. So usually we call these waypoints when working with robots, but in this case we then will call it target for the Robots plugin. How to configure these targets, so to make sure that the robot not only approaches the coordinate itself, but does so in the way that we want it to. We will look at motion types. We will create tools, so to make sure that whatever we attach to the robot in the real world matches our simulation in Grasshopper. We will look at sending these Grasshopper programs to the robot. We will simulate them in Grasshopper to make sure that there are no obvious errors. And we will also go over troubleshooting, so errors, warnings, other problems that you might run into when creating robot programs in Grasshopper. We will go over those, and I hope to make sure that you can actually troubleshoot your own Grasshopper definitions and actually get programs that you can send to the robots without problem. There are 10 videos so far that cover these topics. As I said, some of them specific to universal robots, others are more general. Some videos unfortunately have some audio problems. I had some technical difficulties, but I hope that they are still that you can still understand everything that is said and follow along. Lastly, before starting with the video series, I want to quickly go over why we might use Grasshopper to program robots. As you might know, if you have used any kind of industrial robot, most industrial robots have these graphical user interfaces. They might be more or less graphical depending on the robot brand. So for universal robots, it's these touchscreens where you can program the robot, create waypoints, also create simple logic, use buttons and other kinds of inputs to control the robot. Why might we use something like Grasshopper or other kinds of programming to control the robot? And that is, of course, because we have a lot more flexibility. We can create programs that are fully parametric. And in the case of Grasshopper, which is the benefit of Grasshopper to other kinds of programming, especially text programming, we have a visual feedback of not only the robot, but also the geometry that we use to drive the robot motion. So if you're doing any kind of manipulation, fabrication of something where a 3D shape or a 2D geometry is the basis, then using Grasshopper is the preferred way, because then you can really make sure that the robot motion is dependent on the geometry that you have, and have a very nice workflow of working from the digital geometry and creating the robot motion to then create physical geometry in the real world. If you have any questions either for the robots plugin itself, if you have any questions for the videos, you can of course leave them in the description. Otherwise, you can also have a look at the discussions page on the robots GitHub page. So this is github.com/vsose/robots/discussions. And if you have a question, or also if you might want to suggest a new feature or something that you might want to do that is not possible so far with the plugin, you can also ask it here. And if you have questions about Grasshopper, then you should check out the discourse.mcneil forum /c/Grasshopper. And there, if you have questions very specific to Grasshopper, this is probably the space where you can actually ask them and get good answers in a quite short amount of time, because I will probably not be able to get back to every question that is asked. All right, then that's it for the introduction. If you have any questions, again, let me know, and I'll see you in the next video.